morning slash afternoon. Welcome back. So today we are going to be going through the practice worksheet. So I have a bunch of practice problems to show you, starting with the one that you currently see on your screen. So this is a combination of alkanes, alkynes, and alkenes. Most of these you should be able to do based on the last two PowerPoints that you have seen, but there are a few, particularly down the bottom, that you may not be able to answer, like number 6 and number 13 and number 12. So if you can do all of them but those ones, at this stage you're in a pretty good spot. So we're going to zoom all the way in. Not that far. There we go. And we are going to get started. So first thing we are going to do, as per usual, is we're going to number our carbon chain. This one is fairly simple, so we'll just do 1, 2, 3, 4, 5, 6, 7, 8. It is an 8 carbon chain. They are all single bonds, so we're going to use the prefix for 8, which is oct. And then because it's all single bonds, it's going to be an alkane. We'll use the suffix for an alkane. So the answer to this question is octane. That was a nice easy one to start off with. Alright, moving on to question 2. This one is where we're starting to get a little bit more difficult. We need to first start by circling our side chains. I'm going to go this one and this one to be my side chains. They both have one carbon in it, which means they are both going to be a methyl group. So if we put down methyl here and methyl down here. Okay, so we've got 2 methyl groups. Then once we've worked that out, we're going to then go through and start numbering. So having a look at it, just looking at the picture, it is pretty easy to tell that we are going to be numbering from left to right. So let's do that. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. So again, we have another 8 carbon chain. It is another octane. So we will just chuck that in because there is no double bonds or triple bonds, so it must be an alkane. And there's 8 of them, so prefix oct. Now we have our 2 methyl groups, so we're going to write in our dimethyl. Di meaning 2 and methyl meaning 1 carbon. So we've got a dimethyl octane. The last thing we need to do is write in our locators. So we've got one that comes off of carbon number 2 and the other one comes off of carbon number 5. So it is going to be a 2,5 dimethyl octane. So that is the name for our second one. Hopefully you managed to get that one correct. Alright, moving on. Number 3. So we are going to do exact same thing, exact same steps again and again. Oh, I don't want to change the same color. Thank you. So firstly, circle the side chains. Secondly, number the main chain, which this time is going to go from right to left. 1, 2, 3, 4, 5, 6, and 7. So again, you can number from both sides if you're unsure about something. So if we go through 1, 2, 3, 4, 5, 6, 7. So in this case, if we are numbering from right to left, we have 3, 3, 4. And if we're going from left to right, we've got 3, 5, 5. So actually, yeah, I just confused myself. But yeah, so we are going the right to left way, the 3, 4, 3, 3, 4. Better than, what's that, 3, 5, 5. Yeah, that makes sense, right? I hope so. So I'm going to know from right to left. Right, that way. Give me my pen back, please. Thank you. These are both methyl groups. Methyl. So I typically like to just write this next to it so I don't forget that something exists. Because sometimes when it gets really complex, you can. There is also this little group here, so the double bond. So that means that we are going to have an ene at the end. We're going to do that. So it's an ene group, and that ene is on carbon number 4. That is a 4. Close enough. It is a 7 carbon chain, which means it will be a hept. So we've got a hept 4E. And then There are 2 methyl groups, so again we're going to do a dimethyl. Give myself a little bit more room this time, maybe. So it's a dimethyl heptafluorine, and then both of those methyl groups are often carbon number 3, so we need to do 3,3-dimethyl heptafluorine or 3,3-dimethyl 4-heptene. Either way is fine. So that is the answer to number 3. Okay, we've got this little bit of a complex one, so this one you also may not be able to do. So we might actually skip over this one. If you were wondering, we could just do some basic naming. So if you're wondering, when it's connected like this in kind of like a circle, it's called a cyclic alkane. So typically you end up with a cyclo at the front, something like that. So in this case it'd be a cyclopentane. Oops. Cyclopentane. And this would be counted as side chains. So it would be 1, 3, because you'd do 1, 2, 3, 4, 5. Again, trying to get the smallest possible. So it would be 1,3-diethyl. Cyclopentane. So you don't need to know that at this stage, but there you go. If you wanted to know, there it is. Alright, next. This time we've got no subchains, we just have the double bond here. So we're going to just number it so that that is at the lowest possible, which will be from left to right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a non because it's got 9. It is a double bond, so it's going to be a non-4-ene or 4-non-ene. That one was fairly easy. I liked that one. Alright, number 6. Again, don't really need to know this, but you probably will be able to answer it now that I did number 5 or 4 or whichever one that was that before. It is again a cyclo. It's all connected up in like a little circular shape. So we're going to call it a cyclo. And because there are 3, it's a prop. So cyclo, prop, a. That one is fairly simple. Don't need to add anything else. That is it. That is done. Nice and easy. Alright, back to slightly more complex. So the first, I guess, first thing we need to do with this is kind of work out if the longest carbon chain is anything other than the one that it looks like. And it's not going to be, because these 2 end pieces back here are the same size. So we're just going to pick one, whichever one. Ooh, do that. Pick one, whichever one you want to be your subchain, which I'm going to do the top one because I just like having a straight line across the bottom. And then we need to make sure that this is going to be the smallest number possible, which again is probably going to be from right to left, but we're going to do both ways just to find out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then, why did I put the 7 down there? What am I doing? Yeah, should have rubbed that out. Well, that was not good, but that's okay. And then other way, 1, 2, 3, 4, 5, 6, 7, 8. So on one way we have 2 and 6. On the other way it is 3 and 6. So we're going to go the 2, 6 way, which is right to left. Try and not make a mess rubbing those out. Perfect. Alright, so it is 8 carbons, meaning it will be an oct. There is a triple bond, so it will be an ine, and that triple bond is of number 2, so it will be oct-2-ine, or 2-octine as the base. Whichever way is fine. And then the front part, we have this right here is an ethyl group. We have 1, 2 carbons, so it is going to be an ethyl, and it's of number 6, so it'll be 6 ethyl. Yeah, so 6 ethyl, 2 oct, 2 ine. No. 6-ethyl 2-octine or 6-ethyl oct-2-ine. Whichever way, again, is fine. I need to stop saying that. You're probably sick of hearing me say that. Anyway, so on to number 8. This one looks a little bit funky, but it is actually pretty simple. So we're going to go through and start by circling the subchain, which is just that one right there. And then same as per usual, we will go through and do some numbering. So we're going to start at the top and kind of snake our way down. So 1, 2, 3, 4, 5, and then 6. So it's a 6-carbon chain. So it's going to be a hex. If you have a look, there's no double bonds in here. It's all single bonds, meaning it's an alkane. So it will be a hexane group. And then after that, we need to then label our secondary side chain, which has a single carbon, which makes it a methyl group. And it is coming off carbon number 3. So it will be 3-methyl, put my little dash, 3-methyl hexane. I did not put that right now. Let's try that again. Methyl hexane. There we go. So that's number 8 is 3-methyl hexane. Next, we are moving on to, this one looks quite complex. We are moving on to this one. So we're definitely going to have this and this are subchains. That's definite. And then this is actually our subchain. So if we go through a number, if we start over here, which looks like it's going to be the correct spot, 1, 2, 3, 4, 5, 6, 7. Whereas if we just continued forward, it would be 5, 6, and that would not be the longest. So we've got to go with the longest, even if it looks weird. So that means that the longest is going to be that, and that's the subchain, which is now in blue, but that's fine. We can deal with that. So it is a 7-carbon chain, which means it will be a hept. And it is all single bonds, so it is going to be a heptane. There we go. And then we have our 3 different subchains. So we've got an ethyl group over here, and then we've got 2 methyl groups. There we go. So again, alphabetical order. We are going to start with our ethyl group. Actually, no, I'm going to write down the methyl group first to try and make it easier to write this without making a mistake and having to erase it again. So it is going to be a dimethyl. Dimethyl. And it is a 2, 3. So we've got our 2 numbers there. 2, 3. I'm going to do a dash. And then it is a 4-ethyl. So 4-ethyl. 4-ethyl 2, 3 dimethyl heptane. That was probably the most messy one of those, but that's fine. Hopefully this is making sense to everybody. Alright, starting again, circling our subchains. This time it is pretty straightforward. Secondly, we're going to write down our numbers. So we're going to actually go back and forth on this way to see which one's best. So we'll do 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So if we are going left to right, we have 3, 5, 5, 7. And if we are going right to left, we have 2, 5, 5, 6. So we're going to go right to left because 2, 2, 5, 6 is better than 3, 5, 5, 7. That is hard to remember. So right to left, so this way. Alright, now let's go put those pens back in. Alright, so this up here is going to be a trimethyl because there's 3 methyl groups here. So that's the first thing, and then this one again is an ethyl group. There. So we need to add both of those things in. Again, the alphabetical order does not count the T, it's just off the M. So it's going to be ethyl and then methyl, which either way it would be like that, but that's fine. And it's 8. So we are going to call it, it's an octane, because it's all single bonds and it's got 8. There we go. And then we're going to put our trimethyl group in next. I'm going to run out of space. It's okay. Trimethyl. And that is going to be 2, 4, 6. 2, 4, 6. Oh, I'm kind of out of space. And then let's do that. And I'll change to this color so I can see it. And then that would be the ethyl group. It would be a 5-ethyl. So it'll be 5-ethyl 2,4,6 trimethyl octane. See, it's getting longer, it's getting more complex, but once you know the basic rules, you can just smack them on top of each other and it makes something that's relatively simple to do look really impressive. At least that's my opinion. So that was 5-ethyl 2,4,6 trimethyl octane. Next one, this one is looking quite complex. I'm firstly going to try and work out what my subchains are going to be. So I'm thinking this is going to be a subchain and this is going to be a subchain. So if we go through and do our numbering, 1, 2, 3, 4, 5, 6. So either way, if we had to come down here, it would have been 5, 6 as well. And technically also if we had to come up here, it could have been 1, 2. The reason why I'm circling this one, why am I doing that in blue? I don't want to do that in blue. Try again. The reason why I circled this as our subchain is because I want the double bond to be on the main chain. So as long as the double bond's on the main chain, it's going to make our life 100 times easier than if we have it on the secondary chain. So if you get a choice, put the double bond on the main chain. So that is the reason I chose that. And then out of the two down the bottom, it really doesn't make a difference which one you choose. Just up to personal preference. I felt like doing something a little bit funky today, so I went upwards. So if we name those, we've got here an ethyl, and this one is also an ethyl. So we have a diethyl. That is not how you spell ethyl. We have a diethyl. It is 6 carbons long, and it has a double bond. So it's going to be hexene. And it is off of carbon number 2, so it's 2-hexene. And then we have our 2 methyl groups, so it will be diethyl, and that is off of 3,4, so it'll be a 3,4 diethyl group. So that one seems pretty easy. It looked really complex, but when you break it down into its smaller parts, it's really not that bad. Alright, next one. This one we should also be able to do again. This one is another cyclo. So you don't need to be able to do that, but you probably can just based on this video. So it's a cyclo. There are 4 of them. It's a bute. There is this double bond here, so it's going to be a butene. And because it is in a circle, it does not matter what number location that's on, because no matter what you do, it's going to be one of the 4 sides. So you are always going to start it as number 1. So technically it's cyclobutanene, but you don't need to put that because you can't put it anywhere other than the correct spot, if that makes sense. Hopefully that makes sense to you. So that one's a cyclobutane, nice and easy. This one is a bit funky. So this is what is known as a benzene, and that is something we are going to learn about at a later stage. You do not need to be able to name that yet. You do not need to understand what that is yet, but it is essentially a 6, well, it happens quite frequently, but in this case, it is a 6 carbon chain or ring with alternating double and triple bonds. So that's what it is. We will learn about that a little bit later, or double and single bonds. So hopefully that makes sense. Don't worry about it if you don't understand. We'll come back to that at a later stage. Cool. So that's exciting. Don't need to know that, but there you go. If anyone ever asks you what that little shape is, you will now know. Alright, only 2 more to go. This is exciting. We're almost there. Okay, number 14. So we're going to just circle some of these chains that are not on the main chain. So this is going to be a trimethyl. There we go. And we need to go through and do our numbering system. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So left to right is 3, 4, 9. Right to left is 2, 7, 8. So technically we'll do right to left because that gives us the lowest numbers. Now let's go through and try and get rid of those babies. Oops. Of course I went through the red thing. Alright. And I also should get rid of that 0 there. Lovely. Alright, so that's we've got the trimethyls and we know the numbering system, so let's go through and name them. So a 10 carbon chain is a deck. So it's going to be a deck. It's all single bonds, so it will be decane. And then we have our trimethyl group there, so we'll write that at the front. Trimethyl. And then our numbering is 278. 278. And that's the dash. So it's 278 trimethyl decane. Pretty good. Lucky last. This one looks like a really easy one too. Alright, the only thing we need to name in here is the double bond. So, very easy. We need to count the number of carbons. 1, 2, 3, 4, 5, 6. So it's going to be a hex. And then the carbon number 2 is where the double bond is, and then a ene. So it's hex 2-ene is our very last one. So we have now gone through and worked out all of those. So hopefully that made sense to you, and if you didn't understand how to do it before, hopefully working through it kind of is getting it in your brain what you need to do. And we're going to be moving on to more complex functional groups in the next week's lessons. So hopefully you understand this and have this down pat before we move on to that. I hope you got